Practicing part 3b, where we're going to apply the idea of systems of equations to word problems or real-world scenarios. Now I'm going to go through numbers 1, 2, and 5. I encourage you to try to do some of these on your own before listening to this, and when you get stuck, if you get stuck, to go ahead and then watch it. So I want you to try thinking about some of these first, because I'm going to go through quite a few examples, not leaving you enough to practice on your own, but I recommend that you go ahead and give them a try first. So this very first one, it says, going down the river, a boat went 21 miles per hour. So I'm going to draw myself a little river and get myself a little boat. And we are going 21 miles per hour. And going up the river, so coming back the other way, same boat can only go 3 miles per hour. Interesting. So it goes much faster going down the river than it does going up the river. The current must be pushing against it. It says find the current and the speed of the boat if there were no current. So how fast is the water moving, and how fast is the boat by itself? One way to think about this problem is to think about what are the effects that cause a boat to go fast in a certain direction. And we could say the speed of the boat, so I might call it S with a little b, so speed of the boat, plus we have the speed of the current that are being added together. And when we add those two things together, it looks like we get 21 miles an hour. Now going the other direction, the boat still has its speed. It's heading upriver. So we got the speed of the boat, but this time the current is pushing against us. So the current is pushing against us instead of helping us forward. And so we're going to subtract the current. And when we do that, we only get 3. So the speed of the boat plus the current is 21. The speed of the boat minus the current is 3. And I'm going to change my variables here because these SC's and SB's probably are a little bit confusing. So I'm just going to call it B for boat, speed, and then C for current, B for boat, C for current. Now I have two equations. Both of them are true statements, and I want to figure out the solution. What is B and what is C? To do that, I can use substitution. So if I want to find the easy target to get alone, it looks like all of these are reasonably easy to get alone. I'm going to go for this B right here. So if we add C to both sides of this equation, these two C's are going to cancel out, leaving me with B equals 3 plus C. So B equals 3 plus C. Now I'm going to take that B and I'm going to plug it in for this B. So I know that that B right there is equal to 3 plus C. So I'm going to rewrite the first equation, open parentheses, plus C equals 21. And I'm going to replace that B right there with what I know to be equal to B, 3 plus C. So 3 plus C equals 21. I like to use parentheses whenever I'm substituting, but in this case there's nothing out front and there's no exponents or anything, so I can actually get rid of these parentheses. They're not necessary anymore. So if I combine these, I have a C and a C, so I really have 3 plus 2C equals 21. Subtract 3 from both sides. So take away a 3, take away a 3. Those go away, and I end up with 2C is equal to 18. And then finally C is equal to 9. So my current is 9 miles per hour. So the current of the river is 9 miles per hour. Now I need to figure out what B is, what my boat is. I can take my value of C that I got and I can plug it in right here because I already got B alone here. And so I really just have 3 plus C, or 3 plus 9, which is 12. So B is equal to 12. The boat speed is equal to 12. So 12 by the boat, 12 by the boat. Now let's make sure this actually makes sense in the context of this problem. If I have a boat speed of 12 and the river has a current of 9 miles per hour, add those together and I get 21. That works. Over here I have 12 and the river is pushing against me at 9 miles per hour, so it's taking away 9 miles per hour, and I'm only going 3. That does work too. So this answer checks out. And when you're writing your answer, you would say current, you want to be as clear as possible, 9 miles per hour, and boat is 12 miles per hour. So always label your answer as clearly as possible. Moving on to number 2. Sum of two numbers is 21. Their difference is 5. Find the numbers. Again, we're trying to write two true statements, and you'll see that in every single one of these word problems. There are two true statements that you can make, and those two statements will almost always involve two variables each. So in this case, we have two numbers, and I'm going to call those numbers A and B. So I got to give them some name. So A and B are my two numbers. The sum of them is 21. So A plus B, sum means add, is 21. Over here, the difference is 5. Difference means subtract. So A minus B is 5. Now you might be wondering, well, how do you know it's not B minus A? It doesn't actually matter. It doesn't say find letter A and find letter B. It just says find the numbers. So in this case, once I get my two answers, it doesn't matter which one is called A and which one is called B. So our problem looks very similar to this setup up here where I had B plus C, B minus C. Same type of problem. I'm going to use substitution. So I'm going to solve one of these, and I'm going to pick on this A again, and then I'm going to go ahead and add B to both sides of the equation. So a negative B and a positive B cancel each other, and A is equal to 5 plus B. I plug that in. I know what A is. A is equal to 5 plus B. I'm going to plug that in for this A. So I have 5 plus B, and then I go back to my original equation. It says plus B equals 21. So plus B equals 21. And since I don't need these parentheses because there's nothing being multiplied out front, I have 5 plus B plus B. I can consolidate that a little bit. 5 plus 2B equals 21. And then subtract 5 from both sides. Add a negative 5. Allowing these two cancel out, and 21 plus a negative 5 is going to be 16. So 2b equals 16, and then finally divide both sides by 2 and b equals 8. So I found that one of my numbers is 8. To find out what my a is, my other number, I plug that 8 in for b. So I have a is equal to 5 plus b, a is equal to 5 plus 8, which is equal to 13. So my two numbers, to answer the original question, it says find the numbers. The two numbers are 8 and 13. So getting a little crowded up here, but let's check our work. The sum of two numbers is 21. 8 plus 13 is 21. Check. Difference is 5. 13 minus 8 is 5. Check. Done. So we got that one right. And then finally, one more example, number 5 here. It says, the senior class at High School A and High School B planned separate trips to the water park. So two high schools, A and B, trips to the water park. The senior class at High School A rented and filled 2 vans and 9 buses with 430 students. High School B rented and filled 10 vans and 8 buses with 448 students. It says every van has the same number of students as did the buses. So every van has the same number of students, every bus has the same number of students. How many students can a van carry and how many students can a bus carry? That one is kind of a complicated one. So let's break it down a little bit. We have the High School A rented and filled 2 vans and 9 buses. So over here we have A, and they have 2 vans, 9 buses. And then we have B, and B has, let's see here, 10 vans and 8 buses. So 10 vans and then 8 buses. And they had 448 students. And then the first school said 430 students. So what we can do, because we know that the vans all held the same number of students as each other, we can say 2 vans times number of students per van So I'm going to go with school A right now. I'm going to say I have 2 vans times the number of students per van, and I'm going to call that V. V could be 5, V could be 7, we don't know. So 2 times V, plus, in addition to the 2 vans with however many students per van, we have 9 buses with however many students per bus that we have, and together that's going to be 430 kids. On the other side here we have school B, and I'm going to trace that in purple and use purple for that one. We have 10 vans, and then however many students per van multiplied by 10. We have 8 buses, however many students per bus multiplied by 8, and that's going to equal 448. I just wrote 2 equations. They are both true. They both have 2 variables, and I now need to use some sort of technique, substitution or elimination, to solve that. So we're going to use what we've been using. We're going to use substitution and get one of these alone. Now, when in doubt, I tend to go for the variable with the smallest coefficient. Sometimes there's better strategies so you don't get fractions, but in this case I don't see a clear winner, so I'm going to try to isolate that 2v by itself, and then we're going to solve this problem with that. So let's go ahead and change our color here. What we have, and I'm going to do my work up here, you might need quite a bit of space for this one. I want to get the 9b away from both sides, so I'm going to subtract 9b from both sides of this equation, leaving me with 2v, my original 2v here, is equal to 430 minus the 9b I just subtracted. Then I need to divide everything by 2 to get v alone. So all 3 terms need to be divided by 2, and I get v is equal to 430 divided by 2 is 215, and then 9b over 2 kind of just stays as it is, 9 halves b. So nothing we can reduce there. Now I have v alone, and I used up this equation, but I haven't done anything with this equation right here. So I'm going to rewrite that one and plug in, instead of v, what I know v to be, 215 minus 9 halves b. So let's write that out. We have that bottom equation, 10v, and again we know what v is, so we're going to leave some space for that, plus 8b equals 448. And I'm going to plug in what I know to be b, 215 minus 9 halves b, and let's go ahead and work this out. 10 times all of that, we have 10 times 215 is 2,150. 10 times negative 9 halves, now that's an interesting one. 10 times 9 over 2, we can reduce that to 5 over 1. 5 times 9 is 45, so minus 45b. And then we just keep going along, plus 8b equals 448. Made myself a little more room here, and let's keep on working. We want to consolidate our like terms here on the same side, so 2150 minus, and that's going to be 37b, we consolidate those, equals 448. Finally, we want to get b alone, so we need to get this other term, this negative, or this 2150 off of both sides, so I add a negative 2150 to both sides, and cancels those out here. And on this side, 448 minus 2150, this is where you probably want to start taking out the calculator. And for that we get negative 37b equals negative 1702. And as a last step, we need to divide both sides by negative 37. Again, a good calculator one, so I'll pull that out. And when we do that, we get b is equal to 46. So that means that b, which is the number of students per bus, is 46. So we know how many students each bus carries. Now we need to go back and plug that into this equation, since we know what b is now, and that will allow us to solve for v, how many students per van. So let's right where we've got a little more room, we've got v is equal to 215 minus 9 halves of 46. Now 9 halves of 46. If I'm reducing that, I take my 2, divide that by 2, get 1. On top here I get 23. And now 9 times 23, yeah, that might be a calculator one. 230 minus 23 is 207. So I really have Vans is equal to 215 minus, and solve that how you like, but that's going to come out to 207. And you keep working through, and that's going to equal 8. So what we know now, going back all the way to our original problem, is each bus contains 46 students, and each van contains 8 students. And that was what we were asked to solve.